Hello out there, Mr. Corcoran here with a 5-minute video, approximately, on the math problems that I assigned to the class without preparing them for it. My apologies. Hopefully two things. Number one, hopefully this video helps. Number two, this, in my opinion, is 5th grade math. I taught 4th grade. I currently teach 4th, but I've taught 4th, 5th, and 6th. And this is 5th grade math. And then multiplying this sort of thing is 6th grade math. What's another one? So this is the sort of thing. This is on page 228. Another problem is something like, I don't know, this, like 5 halves plus 3 halves. What's another example? 225. Yeah, this is another one. So 6 and 2/8 decreased by 4 and 5/8. And whoopsie. Is there anything on 224? Oh yeah. So 224, and this is where we're going to start. So 6 and 6/10, and then you have to turn it into something. 11 halves, turn it into something. And then how about another mixed number? 4 and 5/9. 4 and 5/9 equals. All right, so these 1, 2, 3, 4, 5, 6. These 6 problems represent most of the, I think this is a good cross-section of what you see. So we'll start over here, 11 halves, because I like to start with something that is pretty familiar, and students in room 19, we've been talking about halves, right? This is 1 half, that's 2 halves, right? So that would be, that's 1. And here's another 1 half and 2 halves. That's another one, so that's 2. So these 2 are 1, 2, 3, 4. That's 4 halves, right? There's a half here and a half there, here. So that's 4 halves equals 1 plus 1 equals 2. But if you have 11 halves, another way of thinking of it is, if this is 0, whoop, 1, 2, 3, 4, 5, 6. Let's just go there. All right, so if you start at 0 and you have a half, right? So it's 1 half, 2, 3, 4. That is 4 halves. But it's if this is 2 halves, that's 1. This is 2 halves, that's 2. So 4 halves, which is what I did here, 4 halves is the same as 2. Now to get 11, you have to keep going. 4, 5, 6, 7, 8, 9, 10, 11. So as you can see, it's in between 2 whole numbers, so it's going to be something and a half. So 1, 2, 3, that's 4, 5, 6. There we go. 6 and a half. Mr. Corcoran. That's 1. That's 2. That's 3. That's 4. What is that? This is what that is. 5 and 1 half. And that's a mark on my table. But another way to do this is anytime you see a numerator, if your numerator is 11, it's also your divisor. Nope, dividend. Your dividend. Your divisor is the denominator. That's my mnemonic device. Divisor, denominator. So 11 halves is the same as 11 divided by that. And 11 divided by that is this, because 2 times that is this. Hopefully that looks familiar. And then 5 and 1 half. Okay, so that's another way of representing 4 halves. Oh, I already did that. Sorry. Moving on. 11 halves equals 5 and 1 half. So now's a good time for the inverse. If we know that 5 and a half is 11 halves, and 11 halves is 5 and a half, then you can do the reciprocal. You can do the inverse, and you can say, well, if I have 6 whole numbers and 6/10, some students find this easier because the shortcut is this times this plus that. 6 times 10 is 60, plus 6 is 66. But to understand the math behind it, what's happening is this. 6 is the same as 1, right? Plus 1. Plus 1. Again, because 6 is 1, 2, 3, 4, 5, 6. Now, I drew these ones on purpose because 10 tens is 1. And if you do that 6 times, you'll have 60. Well, not 60, but 60 tenths. Okay? 1, 2, 3, 4, 5, 6. 6 whole plus another 6 tenths. Sure enough, 10, 20, 30, 40, 50, 60. 66 tenths. So if you see 66 tenths, you can rename it as 6 and 6 tenths. And if you see 6 and 6 tenths, you can rename it this way. All right, so that's, we got 2 down. We got this one and that one. How about this last one? 4 and 5 ninths. Oh, that's already been 5 minutes. So 4 and 5 ninths is much the same. And this 4, again, I could do 9 ninths, 9 ninths, 9 ninths, 9 ninths 4 times. Or I could say this times this is 36 plus 5 more. 37, 3, 39, 40, 41. 4 ninths is 41. Sorry, 4 and 5 ninths is 41 ninths. So these are examples of how to turn fractions greater than 1 into a mixed number, and mixed numbers into fractions greater than 1. Some people call these improper fractions. I was actually taught that as a kid. However, I have an issue with that because there's a time and a place for those, right? I mean, maybe that's an improper fraction sometimes. Whatever. That's just me being me. This, almost every mathematician I've met calls that a mixed number. I much prefer fractions greater than 1. All right, so this brings us to some addition and subtraction problems. The easiest one of the 3, I believe, is that. If you have 5 halves and someone else has 3 more halves, whenever adding or subtracting fractions, you just add the numerators, leave the denominators alone, and if you have a fraction, remember this, fraction greater than 1, if you have a fraction greater than 1, I think every 5th grade teacher will ask you to do that. Because renaming fractions is an essential part of being a mathematician in 4th and 5th and middle school. So 8 halves, what does that look like? Hopefully you remember, if you have 8 halves, it's the same as counting by halves on a number line 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Oh, and it's on a whole number, so it's 1, 2, 3, yep, you guessed it, 4. And the other way to do that, remember, if you have a fraction, the numerator is the dividend, and the denominator is the divisor. And 8 divided by this is that. So there's your double check. So that's pretty straightforward. Fractions, these are both fractions greater than 1, turning out to be another fraction even greater than 1. It's actually exactly 4. So the last 2 things are mixed numbers. Mixed numbers we have to subtract. Mixed numbers we have to subtract. Let's do this 6 first. So it's 6 whole numbers and a fraction of 2/8. And you're giving some away, you're decreasing by 4 and 5/8. Now this is a really unusual thing because if you have 6 and you have 4, you could do 6 minus 4 is 2, but fractions are strange. You actually have to make sure you deal with this first. And you can't take 2/8 and subtract 5/8. So you have to do something with the 6. What you do is you take 1 out of it. So you have 5 now. Remember that fancy 1 I like to do? So that's 8/8. because you took 1 away from the 6 to make it 5, and another 2 eighths. And if you put that together, you have 10 eighths. With the 4, you don't have to do anything to. 4, 5 eighths. You just have to remember that this is a subtraction problem. Right? So this is 10 eighths, and 10 eighths decreased by 5 eighths is going to give you 5 eighths, and then 5 decreased by 4 is 1. And that's how you do that. I just realized people who really like number lines, you could probably show your thinking something like this. If you really wanted to, 0, but you have to do eighths, which is half, quarter, eighths. So that's 1. Then you could do 2, 3, 4, 5, 6, right? 6 and 2 eighths might be there. And if you're going back 4 and 5 eighths, you do like doop, 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 right? This is pretty cumbersome. This is not easy for everyone, but it's a lot. I think it's a lot more straightforward than this. Okay, so there's one more problem left, and what I intended to be a 5-minute video is actually going to be 5 times 3, but maybe less, because I don't think the last problem will take 5 whole minutes. Well, the last problem we were given is 10 and 5 eighths, and they wanted to decrease that by 3 and 7 eighths. Same thing is going on. You can't take 5 eighths and decrease 7 from 5, but you could take this 10 and make it 9 with an extra 8 eighths. Because then the 8 eighths and 5 eighths can team up, and then you take, so 8 plus 5 gives me 13 or 12? That's 12. No, it is 13. That's 13 eighths. And I'm decreasing it by 7. And that should be 6. 6 eighths. And then here, 9 divided by 3 is 6. So you have 6 and 6 eighths, which is fine for the rest of 4th grade. A lot of students really like to simplify. And if you know your fractions, you know 6 eighths can be divided by 2. And then that gives you 3 fourths. So if you were to say 6 and 3 fourths, that is a more sophisticated way of saying 6 and 6 eighths. Sophisticated? It's definitely in simplest form. I don't know if it's sophisticated. Okay, so those are a couple of problems selected at random from your workbook page. This book here, 224 through 228. And again, this is 5th grade math. What we are doing is more of the simpler stuff, the fractions that we're working on, comparing like these fractions here. This is definitely 4th grade math. So if you do all of these, 216, these types of problems, that's great. That's where we are. Okay. I hope that helped you all. Aloha. Au revoir.